June 14, 1943, Allied airbase near Norwich, England. The morning fog hung heavy over the airfield as Technical Sergeant Marcus Wilkins hunched over the exposed engine of a Douglas C-47 transport aircraft, his skilled hands moving with practiced precision despite the chill. The aircraft was scheduled for a critical supply run to forward positions in North Africa in less than 6 hours, but a persistent fuel delivery problem had grounded it. German engineering experts would have confidently predicted this American machine would remain permanently disabled without proper replacement parts, which were still weeks away from delivery. Before we dive into this story, drop a quick hi in the comments and tell me where you're watching from. It really helps support the channel. What no one could have anticipated was how a resourceful mechanic from Tuskegee, Alabama, armed with nothing but salvaged copper wire and intuitive mechanical genius, would develop a solution so elegant it would not only keep Allied aircraft flying, but eventually transform maintenance protocols across multiple theaters of the global conflict. The distinctive drone of approaching aircraft drew Technical Sergeant Wilkins from his work. He straightened his back, wiping grimy hands on a rag tucked into his belt, as 4 P-47 Thunderbolts returned from their morning patrol over the English Channel. Colonel James Ellison stepped from the squadron headquarters, clipboard in hand, watching the planes circle before landing. "Wilkins," the colonel called, making his way across the tarmac. "Any progress on the transport? General Wilson is breathing down my neck about those medical supplies reaching Oran by tomorrow." "Yes, sir," Wilkins replied, his voice steady despite his growing frustration with the stubborn machine. "But I'm still struggling with the fuel injection system. The replacement parts won't arrive for another 3 weeks according to supply." Colonel Ellison frowned, the lines around his eyes deepening. 3 weeks might as well be 3 years, Sergeant. The field hospital in Oran has 400 wounded men waiting on those supplies." "I understand, sir. I'm trying something unconventional. Give me 2 more hours." Ellison studied Wilkins with a measured gaze. At 32 years old, Marcus Wilkins had been working on aircraft engines since he was 14, starting as a shop assistant at a small airfield near his hometown. Despite his experience and talent, the Army Air Forces had initially restricted him to basic maintenance duties until a shortage of qualified mechanics forced commanders to utilize his skills more fully. 2 hours, Sergeant. After that, we'll have to redistribute the cargo among the fighters and hope for the best." The colonel turned and walked away, already calculating how to divide essential medical supplies among smaller aircraft. On the other side of the conflict, Oberstleutnant Heinrich Wagner of the Luftwaffe's Technical Division sat in his office at an airfield near Calais, reviewing maintenance reports with increasing concern. The numbers before him told a troubling story. Aircraft availability rates were dropping precipitously as parts shortages plagued German maintenance crews. Herr Oberstleutnant, his aide, Lieutenant Klaus Müller, entered with a fresh stack of papers. The latest production figures from the factories in Munich and Stuttgart. Wagner took the documents, his expression souring as he scanned the contents. "These numbers cannot be correct, Müller. They're projecting a 60% reduction in specialized components by August. How are we expected to maintain operational readiness?" "The reports have been verified, sir. Allied bombing has severely impacted our precision manufacturing facilities. The engineers are attempting to simplify designs, but quality is suffering." Wagner removed his glasses and pinched the bridge of his nose. "German engineering has always been our advantage, Müller. Our aircraft may not always match theirs in raw power, but our maintenance requirements have typically been lower, our systems more reliable. If we lose that edge—" He left the thought unfinished, but both men understood the implications. The German Air Force had built its reputation on technical superiority and precision engineering. As that advantage eroded, so too did their ability to maintain air superiority. Back at the Allied airbase, Wilkins had emptied his personal toolkit onto a workbench, sorting through an assortment of wire, clamps, and improvised tools he'd accumulated over years of mechanical improvisation. Growing up in the segregated South had taught him to solve problems with whatever materials were at hand, as proper tools and parts were often unavailable to him. Flight Lieutenant Thomas Baker approached, curiosity drawing him to Wilkins's workspace. The British officer had developed a grudging respect for the American mechanic after Wilkins had saved his Spitfire from the scrap heap following a particularly rough landing 3 months earlier. "What magic are you working today, Wilkins?" Baker asked, peering over the mechanic's shoulder. "Not magic, sir. Just trying to bypass a faulty fuel pressure regulator with some copper wire and prayer," Wilkins replied, without looking up, his fingers twisting a length of wire into a precise configuration. "Sounds rather unorthodox. Your engineering manual approve of such methods?" There was no mockery in Baker's tone, only genuine curiosity. Wilkins chuckled softly. "No manual I've ever seen, sir. But my grandfather had a saying, 'When the right tool doesn't exist, become the right tool.' He could fix anything on our farm with baling wire and determination." "Your grandfather sounds like a wise man," Baker remarked, watching Wilkins' methodical work with the wire. "He was. Taught me that understanding how something works is more important than following prescribed methods. Germans write beautiful manuals, but they never account for what happens when the manual isn't available." Across the English Channel, a similar conversation was taking place in vastly different circumstances. Feldwebel Otto Reichmann, chief mechanic for a Messerschmitt squadron based near St. Omer, was explaining to his commanding officer why 3 aircraft would remain grounded. "The fuel injection control units are showing microscopic stress fractures, Herr Mayer," Reichmann explained, pointing to a diagram. "The tolerances are extraordinarily precise, and without factory replacement parts, the aircraft cannot safely fly." Major Werner Hoffmann slammed his fist on the maintenance desk. "Precision engineering becomes a liability when parts cannot be replaced, Reichmann. The British are flying aircraft held together with wire and sheet metal, while ours sit perfectly designed but useless. With respect, Herr Major, that is the fundamental difference. German engineering demands perfection. The enemy accepts functionality. Their aircraft may fly, but ours fly better. When they fly at all." Hoffmann's expression darkened. "A crude but operational aircraft will always triumph over a superior but grounded one, Feldwebel. Find a solution." "Without proper replacement parts, there is no solution that meets our engineering standards," Reichmann replied stiffly. "Then perhaps our standards have become our weakness," Hoffmann muttered, walking away. As Technical Sergeant Wilkins continued his work on the C-47, he was joined by Private First Class James Washington, a young mechanic recently assigned to the maintenance section. Washington watched in fascination as Wilkins carefully threaded his modified wire assembly into the complex fuel system. "What exactly are you doing, Sergeant?" Washington asked, handing Wilkins a wrench when he gestured for it. "The fuel pressure regulator is failing because its diaphragm spring has weakened," Wilkins explained. "Factory design calls for replacement, but we don't have the part, so instead, I'm creating a bypass circuit using this copper wire as a conductive pathway, essentially tricking the system into maintaining proper pressure." Washington frowned. "But won't that affect the fuel mixture? The flight manual says—" "The flight manual was written by engineers who never had to keep planes flying with half the necessary parts," Wilkins interrupted gently. "Look at it this way. German mechanics are trained to replace components according to precise specifications. We're trained to keep aircraft flying by any means necessary. But their engineering is superior, isn't it? Everyone says German machines are built better." Wilkins paused, choosing his words carefully. "German engineering is excellent, but it's built on assumptions of an ideal world where replacement parts are always available and conditions are always perfect. War isn't perfect. The best engineering acknowledges reality." As Wilkins completed his improvised repair, Colonel Ellison returned, his expression making clear that the 2 hours were up. "Well, Sergeant, can that transport fly or not?" Wilkins closed the access panel and secured it. "She'll fly, sir. The fuel pressure will hold steady enough for the round trip to North Africa. It's not pretty, but it'll work." "You're certain?" "The lives of wounded men depend on those supplies reaching Oran." "As certain as anyone can be in wartime, Colonel. I'd fly it myself if I could." Ellison studied the mechanic's face, then nodded sharply. "Very well. I'll inform the flight crew they're cleared for departure." As the colonel walked away, Washington looked at Wilkins with new respect. "You really think your wire trick will work where German engineering failed?" "It's not about better or worse, son," Wilkins replied, watching as the flight crew approached the aircraft. "It's about appropriate solutions for the circumstances. Sometimes the simplest approach is the most effective." The C-47 took off an hour later, heavily laden with medical supplies. Wilkins watched it climb into the evening sky, his expression revealing none of the anxiety he felt. His improvised solution was now being tested in the most unforgiving environment possible. 3 weeks later, at a Luftwaffe research facility near Munich, Dr. Adalbert Krüger was presenting his findings to a group of senior officers and engineering specialists. The large conference room was filled with the elite of German aviation design, men whose names were associated with the most advanced aircraft in the world. "Gentlemen," Krüger began, adjusting his spectacles, "our analysis of recovered Allied aircraft has revealed a disturbing trend. American and British maintenance crews are employing unauthorized repair techniques that, while crude by our standards, are allowing them to maintain significantly higher aircraft availability rates." He displayed a series of photographs showing improvised repairs from downed Allied planes. This example from a recovered P-47 shows a fuel system modification using simple copper wire that bypasses the need for our precision regulators. Our own maintenance protocols would never permit such improvisation, yet the evidence suggests these wire tricks, as they're calling them, are functioning adequately. General Major Friedrich Fromm, director of Luftwaffe Technical Operations, scoffed openly. "Adequate is not the standard to which German engineering aspires, Dr. Krüger. These improvisations may keep their aircraft flying temporarily, but they surely increase failure rates and reduce performance." "That is what we assumed, Herr General," Krüger replied carefully. "However, our analysis indicates otherwise. While these modifications do not meet our engineering tolerances, they are surprisingly effective in maintaining operational capability. More importantly, they can be implemented with minimal tools and materials, often by mechanics with limited formal training." A murmur of disbelief rippled through the assembled officers. "Are you suggesting we lower our standards to match American improvisation?" one colonel asked incredulously. "I am suggesting, Colonel, that our perfect engineering may be perfectly unsuited to the realities of this war," Krüger answered. "Our aircraft require factory-trained specialists and precision parts. Allied aircraft can be maintained by mechanics using wire and basic tools. The mathematical result of this disparity is becoming evident in operational readiness statistics." The uncomfortable silence that followed was broken by General Major Fromm. "What specific modifications have proven most effective?" Meanwhile, at an expanding Allied maintenance facility in England, Technical Sergeant Wilkins had been promoted to Master Sergeant and placed in charge of a special maintenance unit dedicated to developing field expedient repairs. His wire bypass technique for fuel systems had been so successful that it had been adopted across multiple aircraft types and formalized into a training program for Allied mechanics. "The key insight," Wilkins explained to a group of newly arrived mechanics, "is understanding that the engineering principle matters more than the specific component. A fuel pressure regulator maintains a specific pressure differential. If the factory component fails, we need to reproduce the function, not necessarily the exact part." Among his students were mechanics from various Allied nations, including British, Canadian, and even Free French forces. The diversity of backgrounds had proven unexpectedly valuable, as each national tradition brought different approaches to problem-solving. "Sergeant Wilkins," a British mechanic raised his hand, "my previous commander insisted that these wire modifications must reduce engine efficiency. How do you respond to that criticism?" "A fair question," Wilkins acknowledged, "and in peacetime, he'd be absolutely correct. These modifications do reduce peak efficiency by approximately 8% in laboratory conditions. But war isn't fought in laboratories. A plane flying at 92% efficiency completes its mission. A perfectly engineered plane grounded for lack of parts accomplishes nothing." The practical philosophy behind Wilkins' approach was spreading beyond just maintenance. Aircraft designers at factories in America had begun incorporating more modular, field-serviceable components based on feedback from mechanics like Wilkins. The result was a new generation of aircraft that maintained sophisticated capabilities while being significantly easier to repair under combat conditions. In his office at the airbase, Colonel Ellison was reviewing a report from Allied intelligence detailing the impact of maintenance practices on comparative air power. The numbers were striking. Despite producing fewer total aircraft than Germany in the previous quarter, Allied forces had maintained higher numbers of operational aircraft due to significantly reduced downtime for repairs. A knock at his door interrupted his reading. "Enter," he called. Major General William Wilson stepped into the office, and Ellison rose quickly to attention. "At ease, Colonel," Wilson said, taking a seat across from Ellison's desk. "I've just come from a strategy meeting in London. Your maintenance program is causing quite a stir at headquarters." "Sir?" "Your Master Sergeant's wire tricks, Colonel. Intelligence estimates they've increased our effective air strength by the equivalent of 300 aircraft without building a single new plane, simply by keeping more of our existing aircraft flying." Ellison allowed himself a small smile. "Wilkins would say he's just doing his job, General." "Well, his job is changing the course of the air war. The Germans are scrambling to adapt their maintenance protocols, but their entire industrial and training philosophy works against the kind of improvisation that comes naturally to mechanics like Wilkins." As if summoned by the mention of his name, a knock at the door revealed Master Sergeant Wilkins himself, a folder of papers in hand. "Sorry to interrupt, sir," he said, noticing the General and coming to attention. "Not at all, Sergeant. General Wilson and I were just discussing your maintenance program," Ellison replied. "What do you have there?" "The latest modification procedures, sir. We've expanded the wire bypass technique to hydraulic systems as well. Early tests show it could reduce maintenance downtime on fighters by up to 60%. General Wilson studied Wilkins with interest. "Tell me, Sergeant, where did you learn these techniques? They're certainly not in any Air Force's manual I've seen." "Necessity, sir," Wilkins answered honestly. "Growing up, we couldn't afford to replace things when they broke. We had to fix them with whatever was available. The principles are the same whether you're repairing a tractor or a Thunderbolt. Understand the function, not just the form." Wilson nodded thoughtfully. "A philosophy the Germans seem unable to adopt. Their entire industrial culture revolves around precision components and standardized procedures." "With respect, General," Wilkins ventured, "that's both their strength and their weakness. German engineering is excellent, but inflexible. They design for optimal conditions. We design for reality." At a Luftwaffe airfield in France, the contrast in approaches was becoming painfully evident. Feldwebel Otto Reichmann now had 6 Messerschmitt fighters, grounded due to parts shortages, with no solution in sight. His commanding officer, Major Hoffmann, had become increasingly frustrated with the situation. "The new directive from High Command," Hoffmann said, tossing a document onto Reichmann's workbench, "authorizes field expedient repairs in emergency situations." Reichmann scanned the document with obvious distaste. "Sir, these procedures violate every maintenance principle we've been trained to uphold." "The tolerances alone." "The tolerances don't matter if the aircraft cannot fly, Feldwebel," Hoffmann cut him off. "The Americans are flying daily missions with aircraft repaired using these techniques. Meanwhile, our superior machines sit uselessly in hangars. Their repairs are crude approximations, sir. They sacrifice precision and safety, and yet their planes fly, and ours do not," Hoffmann interrupted again. "Implement the new procedures immediately." "I want 3 aircraft operational by tomorrow morning." Reichmann stiffened. "As you command, Herr Major, but I must register my professional objection to these modifications." "Objection noted," Hoffmann replied coldly. "Now follow your orders." As Reichmann reluctantly began organizing his mechanics to implement the new procedures, he could not shake the sense that something fundamental was shifting in the conflict. The vaunted superiority of German engineering, once a source of national pride and practical advantage, was proving ill-suited to the brutal realities of sustained warfare. The war of attrition favored those who could adapt quickly and maintain functionality with minimal resources. In that arena, the improvisational skills of mechanics like Marcus Wilkins were proving more valuable than the precision engineering of German factories. Back in England, Wilkins' maintenance innovations had caught the attention of Allied High Command. An official delegation was scheduled to visit the airbase to observe his techniques firsthand, with an eye toward implementing them across all Allied air forces. The night before the delegation's arrival, Wilkins sat in the quiet maintenance hangar, performing a final check on a demonstration aircraft. Private Washington entered, carrying 2 cups of coffee. "Thought you could use this, Sergeant," Washington said, handing Wilkins one of the cups. "You've been at it for 14 hours straight." "Thanks, Washington," Wilkins replied, accepting the coffee gratefully. "Just want to make sure everything's perfect for tomorrow." Washington smiled at the irony. "Perfect improvisations for the brass to inspect seems contradictory." "Life is full of contradictions," Wilkins chuckled. "A year ago I was restricted to changing oil and tires because some people thought my skin color determined my capabilities. Now generals want to learn my techniques." "Things change," Washington observed. "Some things," Wilkins corrected him. "The fundamentals remain the same. Understanding how systems work, respecting the machine but not being intimidated by it, finding solutions instead of excuses. You should be the one briefing the generals tomorrow, not just demonstrating techniques." Wilkins shook his head. "I'm more comfortable with engines than officers. Colonel Ellison can handle the talking. I'll stick to showing them how a simple piece of wire can keep a bomber flying when German engineers said it should be grounded." On April 8, 1944, the delegation arrived as scheduled. The group included Air Marshal Richard Phillips of the Royal Air Force, Lieutenant General Jimmy Doolittle of the United States Army Air Forces, and a collection of staff officers and engineering specialists. Colonel Ellison and Master Sergeant Wilkins met them on the tarmac beside a P-51 Mustang fighter that had been prepared for the demonstration. "Gentlemen," Ellison began after introductions were complete, "what you're about to see may seem unorthodox, but the results speak for themselves. Master Sergeant Wilkins has developed maintenance techniques that have increased our operational aircraft availability by 48% in the past 3 months alone." Air Marshal Phillips raised an eyebrow. 48% is a remarkable figure, Colonel. "I trust these modifications don't compromise aircraft performance or pilot safety. We've recorded over 8,000 sorties using these techniques without a single maintenance-related failure, Air Marshal," Ellison answered confidently. "Sergeant Wilkins, please proceed with the demonstration." Wilkins stepped forward, outwardly calm despite the distinguished audience. "Sirs, this P-51 has a simulated failure of its fuel distribution system. Standard maintenance protocols would require replacement of these components." He indicated several precision-machined parts, which would ground the aircraft for approximately 11 days based on current supply timelines. He then proceeded to demonstrate his wire bypass technique, narrating each step in clear, concise language. The senior officers watched with expressions ranging from skepticism to fascination as Wilkins transformed a simple copper wire into a functional replacement for a complex engineered component. "The modification takes approximately 40 minutes to complete," Wilkins explained as he finished. "The aircraft retains 95% of its original performance specifications, and the repair will remain functional for a minimum of 100 flight hours, enough time for proper replacement parts to arrive through normal supply channels." General Doolittle stepped closer to inspect the work. "Ingenious," he murmured. "Simple, effective, and implementable with minimal specialized training. And you've developed similar techniques for other aircraft systems." "Yes, General. We currently have standardized field repair procedures for 16 critical systems across all major Allied aircraft types. Each procedure uses materials commonly available at forward airfields and requires only basic mechanical training to implement." As Wilkins continued to answer technical questions, Colonel Ellison observed the growing excitement among the delegation members. They recognized, as he had months earlier, that Wilkins' approach represented more than just clever repairs. It constituted a fundamental shift in how mechanical problems could be approached under combat conditions. The following day, as news of the successful demonstration spread, a classified intelligence report landed on the desk of General Major Friedrich Fromm at Luftwaffe headquarters in Berlin. The report detailed the Allied maintenance program in alarming specificity, having been compiled from captured documents and interrogations of downed pilots. Fromm read the report with growing concern, then summoned his chief of staff, Oberst Wilhelm Krebs. "Oberst," Fromm said when Krebs arrived, "have you reviewed the latest intelligence on Allied maintenance protocols?" "Yes, Herr General. The so-called wire tricks they've implemented across their air forces." "And your assessment?" Krebs hesitated. "From a purely engineering standpoint, their methods are crude and imprecise, but from an operational perspective—" He paused, choosing his words carefully. "From an operational perspective, their approach is proving remarkably effective. They are maintaining higher aircraft availability rates despite inferior manufacturing capacity." Fromm nodded grimly. "Our perfect engineering is being defeated by American improvisation." "The implications extend beyond just aircraft maintenance, Oberst. This represents a clash of industrial philosophies, precision versus adaptability." "What are your orders, General?" "Implement their techniques wherever possible," Fromm replied with obvious reluctance. "But I fear we face a more fundamental problem than just maintenance protocols. Our entire industrial system is built around precision engineering. We cannot simply reverse course overnight." As Fromm had intuited, the challenge for German forces went deeper than specific repair techniques. The improvisation that came naturally to Allied mechanics like Marcus Wilkins was at odds with the rigid, procedure-oriented training of their German counterparts. What looked like simple wire tricks to German observers was actually the manifestation of a more adaptive, pragmatic approach to problem-solving, one that was proving decisively advantageous as the war stretched resources thin on all sides. Interestingly, this disconnect extended beyond just military applications. At a Reich Ministry of Armaments meeting in Berlin, Albert Speer was expressing similar concerns about German manufacturing philosophy. "Our pursuit of engineering perfection has become counterproductive," Speer told assembled industrial leaders. "While we debate tolerances measured in micrometers, the Americans are producing functional aircraft, tanks, and trucks in quantities that overwhelm our precision advantages." One industrialist objected, "Are you suggesting we abandon our engineering standards, Herr Minister? German precision is what distinguishes our products." "I am suggesting," Speer replied evenly, "that perfect weapons that cannot be built in sufficient numbers or maintained in the field are perfectly useless. We must adapt or face the consequences." At the Allied Air Base in England, Master Sergeant Wilkins was unaware of the strategic impact his practical approach was having. For him, the work remained focused on keeping aircraft flying and crews safe. As May 1944 approached, the tempo of operations increased dramatically in preparation for the long-anticipated cross-channel invasion. "We're running 3 shifts now," Wilkins told Colonel Ellison during a rare quiet moment. "The wire bypass program has been fully implemented across all squadrons, and we've trained over 200 mechanics in the techniques." "The results speak for themselves," Ellison replied, reviewing the latest readiness reports. "Operational aircraft availability is at 92%, the highest in the entire European theater." "The real test will come with the invasion, sir. Our techniques are designed for high-volume operations under adverse conditions. That's exactly what we'll face once we establish forward bases in France." Ellison nodded thoughtfully. "General Doolittle has authorized immediate implementation of your program across all 8th and 9th Air Force units. Your maintenance manual is being printed as we speak. 50,000 copies for distribution to all Allied air forces." Wilkins blinked in surprise. "My maintenance manual, sir?" "Official title, Field Expedient Aircraft Maintenance Procedures, but everyone's already calling it Wilkins Wire Tricks. Your name is right on the cover, Sergeant. First edition is already on its way to Washington for the archives." For a moment, Wilkins was speechless. Growing up in segregated Alabama, he had never imagined his name would appear on an official military manual, let alone one being distributed to mechanics around the world. "I don't know what to say, Colonel." "You don't need to say anything, Sergeant. Your work speaks for itself. I've also put you in for a promotion and the Legion of Merit. The paperwork is already processing through channels." Before Wilkins could respond, an aide rushed into the office. "Colonel, urgent message from Group. The Germans have launched a major air offensive against our forward bases. All available aircraft are ordered to scramble immediately." As sirens began to wail across the airfield, Ellison and Wilkins rushed outside to see mechanics and pilots running to their aircraft. The battle that would test Wilkins' maintenance innovations under the most demanding conditions possible was about to begin. The German air offensive of May 1944 was intended as a decisive blow against Allied air power in preparation for the expected cross-channel invasion. Instead, it became a stark demonstration of how fundamentally the balance of air power had shifted, due in no small part to the maintenance innovations pioneered by Master Sergeant Marcus Wilkins. As the air raid sirens wailed across the base, Wilkins and his maintenance team sprang into action. The morning status report had shown 92% of aircraft operationally ready, a remarkable figure that would have been impossible before the implementation of Wilkins' wire techniques. Within minutes, dozens of P-51 Mustangs and P-47 Thunderbolts were airborne, climbing rapidly to meet the incoming German formation. "Maintenance control to all sections," Wilkins radioed from the operations building. "Prepare for crash repairs on returning aircraft, priority on fuel systems, hydraulics, and control surfaces. Wire bypass kits ready at all stations." Colonel Ellison stood beside him, monitoring the tactical display as Allied and German aircraft converged over the English Channel. "The Germans have committed over 200 aircraft to this raid," he noted grimly. "Intelligence suggests it's an all-out effort to degrade our capabilities before the invasion." "They're too late," Wilkins replied with quiet confidence. 6 months ago, they might have caught us vulnerable. Not anymore." The air battle raged for nearly 3 hours, with waves of German bombers and fighters pressing their attack against fierce Allied resistance. As the first damaged Allied aircraft began returning to base, Wilkins left the control room to oversee the emergency repair operations personally. A P-51 Mustang landed with hydraulic fluid streaming from its undercarriage, the pilot barely maintaining control as the fighter skidded to a stop at the end of the runway. Ground crews rushed to the aircraft, and Wilkins was among the first to reach it. "Hydraulic lines severed by flak," he assessed quickly, examining the damage. "Primary and secondary systems compromised." The pilot, Lieutenant Michael Reynolds, climbed down from the cockpit, his face streaked with sweat and grime. "She handled like a brick on landing, Sergeant. Is she finished for the day?" "Not even close, Lieutenant," Wilkins replied, already signaling for his maintenance team to bring a wire bypass kit. "Give us 40 minutes." 40 minutes? Reynolds looked incredulous. "The hydraulic system is completely shot." "The factory hydraulic system is shot," Wilkins corrected him. "We're going to give you a field expedient replacement that will have you back in the fight before the Germans can reorganize for a second wave." As Wilkins and his team worked on the damaged fighter, similar scenes were playing out across the airfield. Aircraft that would once have been grounded for days or weeks were being rapidly returned to operational status, using the techniques that had now become standard across Allied air forces. At a German airfield near Lille, France, Feldwebel Otto Reichmann was facing a very different situation. The returning Messerschmitt fighters of his squadron had suffered significant damage in the engagement, and despite recent directives to implement Allied-style field repairs, his maintenance crews were struggling to adapt. "The wire bypass procedure is not working correctly, Herr Major," Reichmann reported to Major Hoffmann as they stood amid the damaged aircraft. "The tolerances are too precise for our mechanics to replicate with hand tools." Hoffmann's expression darkened with frustration. "The Americans are making it work, Reichmann. Their mechanics have these aircraft flying again in hours, not days." "Their mechanics were trained differently, sir. Our men are taught to follow precise procedures with exact specifications. This improvisation does not come naturally to them." "Then they must learn," Hoffmann snapped, "or we lose this air war before summer's end." Across the Channel, Wilkins' maintenance teams had worked miracles. By late afternoon, 78% of the damaged aircraft had been returned to operational status, an achievement that would have been unimaginable before the implementation of his wire bypass techniques. Colonel Ellison found Wilkins inspecting a freshly repaired P-47, the mechanic's uniform stained with hydraulic fluid and engine oil. "Remarkable work, Sergeant," Ellison said, genuine admiration in his voice. "Intelligence reports the Germans are in disarray. They expected to ground our air forces for at least 48 hours. Instead, we're launching counter-raids this evening." Wilkins nodded, wiping his hands on a shop rag. "The wire tricks worked exactly as designed, sir. Simple, reliable field repairs that maintain essential functionality." "It's more than just repairs, Wilkins. You've changed the fundamental equation of air warfare. Aircraft availability has become as important as aircraft performance, and in that arena, we now hold an overwhelming advantage." By the following morning, the strategic implications were becoming clear to Allied command. The German air offensive, intended as a crippling blow, had instead revealed their own vulnerability. Unable to repair their aircraft quickly enough to maintain operational tempo, Luftwaffe units were being ground down by sustained Allied pressure. Air Chief Marshal Sir Arthur Tedder summoned Colonel Ellison and Master Sergeant Wilkins to his headquarters near London on May 18th. The elegant conference room, with its polished table and wall maps, seemed a world away from the grease and grime of aircraft maintenance. "Gentlemen," Tedder began once they were seated, "I've reviewed the after-action reports from the recent engagement. The performance of your maintenance units was extraordinary, Colonel Ellison." "Thank you, sir," Ellison replied, "but the credit belongs to Master Sergeant Wilkins and his innovative repair protocols." Tedder turned his attention to Wilkins. "Your wire bypass techniques have transformed our maintenance capabilities, Sergeant. But I'm curious, did you anticipate the strategic impact when you first developed these methods?" Wilkins considered the question carefully before answering. "Not initially, sir. I was focused on solving immediate problems with available materials. It was only later that we recognized the broader implications for sustained operations." "Necessity is the mother of invention," Tedder observed with a slight smile. "But what you may not know is how profoundly your innovations have disrupted German operations. According to intelligence reports, they are attempting to implement similar techniques with limited success." "They're struggling to adapt, sir." "Precisely. Their entire maintenance philosophy is built around precision engineering and factory-specified repairs. Their mechanics lack the improvisational training that seems to come naturally to Allied personnel, particularly Americans." Colonel Ellison nodded his understanding. "German engineering emphasizes precision at the expense of adaptability. Our approach values function over form." "A cultural difference with strategic implications," Tedder agreed. "Which brings me to the purpose of this meeting. Supreme Headquarters has authorized the establishment of a specialized training unit to formalize and expand Sergeant Wilkins' maintenance innovations across all Allied air forces. Colonel Ellison, you will command this unit. Sergeant Wilkins, you are being commissioned as a first lieutenant, effective immediately." Wilkins sat stunned, unable to find words. "Your promotion papers have already been processed," Tedder continued. "Congratulations, Lieutenant Wilkins. Your new unit will be tasked with training mechanics from all Allied nations in your techniques, as well as developing new field expedient repairs for emerging challenges." The newly commissioned Lieutenant Wilkins finally found his voice. "Sir, I'm honored, but there may be some who object to my commission." Tedder's expression hardened slightly. "Those objections have been considered and overruled at the highest levels, Lieutenant. Your demonstrated abilities and the strategic value of your innovations take precedence over any outdated prejudices. Is that clear?" "Yes, sir." "Thank you, sir." Meanwhile, at Luftwaffe High Command in Berlin, a very different conversation was taking place. General Major Friedrich Fromm had called an emergency meeting of his senior technical staff to address the crisis in aircraft availability. "The situation has become critical," Fromm told the assembled officers. "Our operational readiness has fallen to 64% across all frontline squadrons. The Americans, in contrast, are maintaining rates above 85% despite absorbing similar damage." Oberst Wilhelm Krebs, Fromm's chief of staff, distributed a translated copy of the captured Allied maintenance manual, the very document that bore Lieutenant Wilkins' name. "This is their secret weapon, gentlemen. Not a new aircraft or weapon, but a maintenance philosophy that emphasizes expedient functionality over engineering perfection." Dr. Adalbert Kruger, who had warned about this development months earlier, studied the manual with professional interest. "These procedures violate every principle of German engineering," he noted, "and yet the results are undeniable. Can we implement these techniques effectively?" Fromm asked. Kruger hesitated. The procedures themselves are not complex, Herr General. The difficulty lies in the mindset required to execute them. Our mechanics are trained to think in terms of precision specifications and factory-authorized procedures. These American techniques require a fundamentally different approach, one that values improvisation and functional approximation. Then we must retrain our mechanics, Fromm declared. With respect, General, such retraining would require months we do not have, Kruger replied. Moreover, it runs counter to our entire industrial culture. German engineering has always prided itself on precision and perfection. Pride will not keep our aircraft flying, Doctor, Fromm said grimly. If we cannot adapt to this American approach, the consequences for our air capabilities will be severe. As the implications of this maintenance disparity became clear to German leadership, a sense of growing alarm spread through their industrial and military establishments. What had begun as a simple field expedient repair technique developed by a resourceful American mechanic had evolved into a strategic vulnerability that threatened to undermine a core German advantage. By early June 1944, as Allied forces prepared for the cross-channel invasion, the new maintenance training unit commanded by Colonel Ellison and Lieutenant Wilkins was operating at full capacity. Mechanics from American, British, Canadian, Free French and other Allied air forces cycled through an intensive program that taught not just specific repair techniques, but a new approach to problem solving. The wire itself is not the innovation, Lieutenant Wilkins explained to a class of 50 mechanics gathered in a hangar. The innovation is recognizing that engineering principles can be satisfied through multiple means. When factory components fail, we need to restore function, not necessarily form. A British mechanic raised his hand. But surely precision engineering exists for a reason, sir. German aircraft components are manufactured to exacting tolerances because those specifications optimize performance. Absolutely correct, Wilkins acknowledged. In ideal conditions, precision-engineered components will deliver superior performance. But war creates the least ideal conditions imaginable. A perfectly engineered aircraft, grounded for lack of parts, has a combat effectiveness of 0. An imperfectly repaired aircraft that can fly has preserved most of its combat potential. This philosophy, pragmatic, adaptable, focused on maintaining functionality in adverse conditions, was spreading beyond just aircraft maintenance. Similar approaches were being adopted for ground vehicles, field communications, and even weapons systems. The cultural emphasis on improvisation and adaptability that had long been part of American technical tradition was proving to be a decisive advantage in sustained warfare. On the German side, efforts to implement similar techniques continued to falter. Despite the distribution of captured Allied maintenance manuals and explicit orders to adopt field-expedient repairs, Luftwaffe maintenance units struggled to achieve the same results. At a maintenance training facility near Munich, Oberleutnant Franz Weber was attempting to teach Allied wire bypass techniques to a class of German mechanics. The frustration was evident on both sides. The procedure calls for approximating the pressure differential using the wire's natural tension, Weber explained, demonstrating on a disassembled fuel system. You must feel when the tension is correct. But what is the exact specification for the tension? One mechanic asked. What tool do we use to measure it? There is no exact specification, Weber replied with growing frustration. That is the point of the technique. You must develop a feel for when it is correct. The mechanics exchanged uncomfortable glances. Their entire training had emphasized precise measurements and adherence to documented specifications. The idea of relying on intuitive feel ran counter to everything they had been taught about proper engineering. Perhaps if we created a calibration tool to standardize the tension, another mechanic suggested. Weber sighed deeply. By the time we designed and manufactured such a tool, the Americans would have repaired 50 aircraft using their fingers and experience. This is the advantage we must overcome. On June 6, 1944, Allied forces launched the long-awaited invasion of Normandy. As ground troops stormed the beaches, the largest air armada in history provided cover overhead. The months of preparation using Wilkins' maintenance techniques had paid off dramatically. Allied air forces achieved an operational readiness rate of 91% on D-Day, allowing them to establish immediate air superiority over the invasion beaches. At a forward airstrip, hastily constructed in the Normandy countryside just days after the initial landings, Lieutenant Wilkins supervised the establishment of a field maintenance unit. The conditions were primitive: mud, limited tools, no permanent structures, precisely the environment where his wire techniques proved most valuable. "Set up the bypass kit stations here," he instructed the maintenance chief, indicating a relatively dry area under canvas shelters. "Priority on fighters first, then transport aircraft. Standard 40-minute turnaround protocol for all repairable damage." Colonel Ellison arrived by jeep, surveying the makeshift airfield with satisfaction. "First fighter squadron lands in 30 minutes, Lieutenant. How ready are we?" "Fully operational, sir. We can handle up to 20 aircraft simultaneously with current personnel. The wire bypass kits are prepared and distributed." Ellison nodded approvingly. "Intelligence reports the Germans are struggling to maintain air operations from their fixed bases. Their maintenance infrastructure is too dependent on permanent facilities and specialized equipment." "Our advantage," Wilkins observed. "We can operate effectively from any field flat enough for aircraft to land. The wire bypass techniques work as well in a muddy field as they do in a proper hangar." As predicted, the first P-47 Thunderbolts began arriving 30 minutes later, many bearing damage from encounters with German anti-aircraft fire. Wilkins's maintenance team swarmed over the aircraft, applying the now standardized field repairs with practiced efficiency. Major James Harrington, commander of the fighter squadron, approached Wilkins as his plane was being serviced. "Remarkable operation you're running here, Lieutenant. My crew chief tells me you're the man behind these wire tricks everyone's using." "Just one of many contributors, sir," Wilkins replied modestly. "Well, those contributions are saving lives. Before your techniques were implemented, my squadron averaged 60% operational readiness during sustained operations. Now we're maintaining above 85%, despite operating from this mud pit." The contrast with German maintenance capabilities was becoming increasingly stark. At Luftwaffe airfields across France, maintenance crews struggled with parts shortages and rigid procedures that left many aircraft grounded. The attempts to implement Allied-style field repairs continued to yield disappointing results, hampered by both technical and cultural barriers. At a German airfield near Caen, Feldwebel Otto Reichmann was attempting to apply wire bypass techniques to a damaged Focke-Wulf 190 fighter. The repair manual translated from captured Allied documents lay open beside him, but the procedure wasn't working correctly. "The pressure regulator continues to fluctuate," he reported to Major Hoffman, who was watching the attempted repair with growing impatience. "The wire conduct path is not maintaining consistent resistance." "The Americans make this work routinely," Hoffman insisted. "What is the difficulty?" Reichmann chose his words carefully. "The American mechanics appear to rely heavily on intuitive adjustments, Herr Major. Our training emphasizes precise measurement and specification. We are attempting to standardize a process that they deliberately leave unstandardized." Hoffman's frustration was palpable. So German engineering precision has become a liability rather than an asset. "In this specific context, yes," Reichmann admitted reluctantly. "Their approach values adaptability over precision. Under current conditions, that approach is proving more effective." By late June, the strategic implications of this maintenance disparity had reached the highest levels of German command. Field Marshal Erhard Milch, responsible for Luftwaffe production and maintenance, convened an emergency conference of industrial and military leaders to address the crisis. "The situation is becoming untenable," Milch informed the assembled officials. "Allied air forces are maintaining operational readiness rates that we cannot match. Their field-expedient maintenance techniques allow them to operate effectively from forward airfields with minimal infrastructure, while our aircraft require specialized facilities and factory components." Albert Speer, Minister of Armaments and War Production, studied the reports with concern. "This represents a fundamental challenge to our industrial philosophy," he observed. "German engineering has always emphasized precision and standardization. The Allied approach, particularly the American techniques, values improvisation and adaptation." "Can we not simply adopt their methods?" asked one general. Dr. Kruger, who had been invited to provide technical perspective, shook his head. "We have been attempting to implement these wire tricks for several months now. The results have been disappointing. Our mechanics are trained to follow precise procedures with exact specifications. The American approach requires a different mindset, one that our training and industrial culture do not currently support." "Are you suggesting our superior German engineering has become a weakness?" another officer asked incredulously. "In the specific context of sustained warfare with disrupted supply lines, yes," Kruger replied bluntly. "Precision engineering relies on an infrastructure of specialized manufacturing, trained personnel, and intact supply chains. As those break down under Allied bombing, the advantages shift to systems that can be maintained with minimal resources and improvised solutions." Speer leaned forward, his expression grave. "If we cannot adapt our maintenance approach quickly, what are the implications for air operations?" Field Marshal Milch's answer was sobering. "Continued decline in operational readiness rates. Within 3 months, we may struggle to maintain 50% of our aircraft in flying condition. The Americans, meanwhile, will likely sustain rates above 80%. The room fell silent as the implications sank in. What had begun as a simple maintenance innovation had evolved into a strategic advantage that threatened to accelerate the collapse of German air power. In England, unaware of the strategic crisis he had helped precipitate, Lieutenant Wilkins was preparing to deploy to France with an expanded maintenance training unit. His promotion to first lieutenant had been followed by a Bronze Star Medal for his contributions to Allied air power, and his wire bypass techniques had been formally incorporated into official maintenance protocols. Colonel Ellison found him in the maintenance hangar, reviewing equipment manifests for the Channel crossing. "Good news, Lieutenant," Ellison announced. "Your maintenance manual has been translated into 12 languages and distributed to all Allied air forces. Even the Russians are implementing your wire bypass techniques on their Eastern Front aircraft." Wilkins looked up from his paperwork. 12 languages? That's unexpected, sir. Your innovations have gone global, Wilkins, and the impact is being felt across the entire air war. Intelligence estimates the Germans are losing 3 aircraft to maintenance issues for every one lost in actual combat. They simply cannot keep their planes flying. "Have they attempted to adopt our techniques?" "They've tried," Ellison confirmed, "but according to intelligence, they're struggling to make them work effectively. Their entire industrial and training philosophy runs counter to our improvised approach. German mechanics are trained to follow precise procedures with exact specifications. Our techniques require a fundamentally different mindset." "Adaptability versus precision," Wilkins observed thoughtfully. "Exactly. And in this war, adaptability is proving the greater advantage." On July 2nd, Wilkins's expanded maintenance unit arrived in Normandy, establishing operations at a forward airfield near Carentan. The conditions were primitive: muddy fields, canvas shelters, limited tools. But the wire bypass techniques were designed precisely for such environments. "Set up the maintenance stations according to standard field protocol," Wilkins instructed his team. "Priority on fighter aircraft first, then tactical bombers. Standard 40-minute turnaround target for all repairable battle damage." The system quickly proved its worth, as Allied aircraft returned from missions over German positions, many bearing damage from flak and fighter encounters. Wilkins's team swarmed over the damaged planes, applying wire bypass repairs with practiced efficiency. Aircraft that would once have been grounded for days or weeks were returned to operational status in hours or even minutes. As July progressed, the impact of this maintenance disparity became increasingly evident in the skies over Normandy. Allied air forces maintained relentless pressure on German positions, while Luftwaffe appearances became increasingly rare. What had begun as rough parity in aircraft numbers had transformed into overwhelming Allied air superiority, driven not by production advantages, but by the ability to keep existing aircraft flying, despite battle damage and parts shortages. At Luftwaffe headquarters in Berlin, the mood had turned grim. Daily status reports showed operational readiness rates continuing to decline despite desperate efforts to implement Allied-style maintenance techniques. "The latest figures are troubling, Herr Feldmarschall," Oberst Krebs reported to Field Marshal Milch. Average operational readiness across all front-line squadrons has fallen to 51%. Some forward units are reporting rates below 40%. Milch studied the numbers with a growing sense of defeat, and our efforts to implement the American wire techniques. Limited success at best. Our mechanics continue to struggle with the improvisational aspects of the procedures. They seek precision, where the Americans embrace approximation. A cultural difference with strategic implications, Milch observed, echoing unknowingly the words Air Chief Marshal Tedder had used months earlier. Has Dr. Kruger's technical team made any progress in standardizing these techniques to match our training protocols? They have developed improved documentation and measurement tools, Krebs replied. But by the time these refinements reach our forward maintenance units, the Americans have typically moved on to even newer improvisations. We are constantly chasing their innovations. Milch was silent for a long moment, contemplating the implications. The irony is palpable, Oberst. German engineering has always prided itself on technical superiority. Yet here we are, defeated not by a superior technology, but by the simplest of innovations, the creative use of ordinary wire. The Americans value function over form, Herr Feldmarschall. In this specific context, their approach has proven more effective. By August 1944, as Allied forces broke out from the Normandy beachhead and began the rapid liberation of France, the maintenance disparity had become a decisive factor in the air war. Lieutenant Wilkins's wire bypass techniques had been fully implemented across all Allied air forces, allowing them to maintain unprecedented operational readiness rates despite increasingly forward deployments and stretched supply lines. At a newly captured German airfield near Orléans, Wilkins was granted permission to examine abandoned Luftwaffe maintenance facilities. What he found provided fascinating insights into the cultural and technical differences that had given Allied forces such a decisive advantage. Their tools and equipment are excellent, he noted to Colonel Ellison as they toured the facility. Far superior to what we typically have available, but they're also highly specialized, designed for precise factory-specified repairs rather than field improvisation. The perfect tools for a war without supply disruptions, Ellison observed. Exactly, sir. Their engineering is outstanding, but it assumes ideal conditions. Our approach assumes the worst conditions and develops solutions accordingly. As they examined the German maintenance documentation, Wilkins noted with surprise several attempts to implement wire bypass techniques similar to his own innovations. They were trying to adopt our methods, he remarked, studying the German diagrams. Without success, apparently, Ellison replied. Intelligence reports their mechanics struggled to achieve the same results. They kept trying to standardize procedures that are inherently adaptive. They missed the fundamental principle, Wilkins agreed. The wire technique works because it adapts to conditions, not because it adheres to specifications. It's about understanding the underlying function rather than replicating the exact form. By September, as Allied forces approached the German border, the strategic impact of Wilkins' maintenance innovations had become clear to both sides. What had begun as a simple field expedient repair technique had evolved into a decisive advantage that accelerated the collapse of German air power, and by extension their ability to defend their territory. At Supreme Headquarters Allied Expeditionary Force, General Dwight D. Eisenhower was reviewing the latest intelligence assessment of German air capabilities. Luftwaffe operational readiness has fallen below 40% across all sectors, the intelligence officer reported. They simply cannot keep their aircraft flying. Our maintenance advantage has become as important as our production advantage, Eisenhower nodded thoughtfully. A simple innovation with profound consequences. Has the maintenance disparity been quantified? Yes, General. For every 100 aircraft each side loses to combat, the Germans lose an additional 120 to maintenance issues. We lose fewer than 40. The cumulative effect over time has been devastating to their air capabilities. In Berlin, the recognition that maintenance philosophy had become a decisive factor in the air war led to soul-searching among German industrial and military leaders. At a strategy conference in late September, Albert Speer addressed the uncomfortable truth directly. "We assumed technical superiority meant engineering perfection," he told assembled officials. The Americans understood that true technical superiority means adaptation to real-world conditions. Their wire tricks, as simplistic as they seem to our engineers, represent a fundamentally different approach to problem-solving, one that has proven more effective under wartime conditions. On October 10, 1944, Lieutenant Marcus Wilkins was promoted to captain and awarded the Silver Star for his contributions to Allied victory. The citation noted that his maintenance innovations had transformed the fundamental equation of air warfare and contributed decisively to Allied air superiority. At the promotion ceremony, attended by senior officers from multiple Allied nations, General Jimmy Doolittle himself pinned the new rank insignia on Wilkins' uniform. "Your wire tricks changed the course of this air war, Captain Wilkins," Doolittle told him. "A simple innovation with strategic impact." "Thank you, General," Wilkins replied, "though I still think of it as just solving problems with available materials." "Sometimes the most profound innovations are the simplest," Doolittle observed. "German engineering sought complexity and perfection. You recognized that adaptability and functionality were more valuable under combat conditions." As Allied forces pressed deeper into Germany in the closing months of 1944, captured documents revealed the extent to which Wilkins's maintenance innovations had disrupted German air capabilities. A classified assessment prepared for Luftwaffe High Command in November contained a stark admission. The inability of our maintenance philosophy to adapt to American wire techniques has become a decisive factor in our loss of air superiority. The document went on to explain that the disparity in aircraft availability had created a cascading effect across all aspects of air operations. With more aircraft consistently available, Allied forces could maintain higher sortie rates, which in turn increased combat losses for German units, further straining their maintenance capabilities in a vicious cycle. Most revealing was the conclusion. The American maintenance approach represents not merely a technical innovation, but a fundamentally different problem-solving philosophy, one that values adaptability over precision, functionality over perfection. Under sustained wartime conditions, their approach has proven decisively superior. By January 1945, as Allied forces closed in on Germany from east and west, Captain Wilkins had been tasked with establishing a comprehensive maintenance training program for the post-war air forces. His wire bypass techniques, once an emergency expedient, had evolved into standard doctrine that would influence maintenance philosophy for decades to come. "The key lesson," he explained to Colonel Ellison as they reviewed the training curriculum, "isn't about wire or specific techniques. It's about approaching technical problems with flexibility and understanding the underlying principles rather than just following procedures." "A lesson that extends well beyond aircraft maintenance," Ellison observed. "Exactly, sir. German engineering was excellent, probably superior to ours in many ways. But they built systems that required ideal conditions to maintain. We built systems that could adapt to the worst conditions imaginable." "Function over form," Ellison summarized. "Adaptability over precision." "Yes, sir, and in war that made all the difference." In the final analysis, the wire bypass techniques developed by Marcus Wilkins represented more than just clever repairs. They embodied a fundamentally different approach to technical problems, one that valued practical solutions over theoretical perfection, adaptation over standardization, functionality over ideal specifications. Under the demanding conditions of global warfare, this approach had proven decisively superior. The German failure to effectively counter these innovations stemmed not from lack of technical skill, but from a deeply ingrained industrial and training philosophy that emphasized precision engineering above all else. By the time German leadership recognized the strategic implications of this maintenance disparity, their ability to adapt had been crippled by industrial disruption and cultural inertia. What began as a simple wire trick developed by a resourceful mechanic from Tuskegee, Alabama evolved into a strategic advantage that helped accelerate the Allied victory. The lesson, that adaptability often trumps perfection under adverse conditions, would influence military technical thinking for generations to come. In March 1945, As American forces pushed deeper into Germany, a captured Luftwaffe technical officer made a remark that perfectly encapsulated the strategic impact of Wilkins' innovations. When we first heard about the American wire tricks, we dismissed them as crude approximations, unworthy of proper engineering attention. By the time we recognized their true significance, it was too late. In that moment of dismissal, the war was lost. After the war, Captain Marcus Wilkins would go on to a distinguished career in both military and civilian aviation. His maintenance innovations would be incorporated into standard procedures for air forces around the world, and his emphasis on adaptability and functional solutions would influence aircraft design philosophy for decades. The wire bypass technique that began as an emergency expedient in an English airfield became a symbol of American technical pragmatism, a simple innovation that demonstrated how understanding fundamental principles and adapting to real-world conditions could triumph over even the most precise engineering. German engineering experts, who had once dismissed Wilkins' wire tricks as crude approximations, eventually came to recognize the profound lesson they embodied. As one former Luftwaffe technical officer remarked years later, "We built perfect machines that required perfect conditions. The Americans built adaptable machines that functioned under any conditions. History has shown which approach was wiser." The legacy of Marcus Wilkins and his wire tricks serves as a reminder that true innovation often comes not from complex technology, but from a fundamental shift in approach, from seeing problems differently and finding solutions where others see only obstacles. In the skies over Europe, this simple insight helped change the course of history. And that concludes our story. If you made it this far, please share your thoughts in the comments. What part of this historical account surprised you most? Don't forget to subscribe for more untold stories from World War II and check out the video on screen for another incredible tale from history. Until next time.